from Packet Clearinghouse. We're a non-profit based in San Francisco, California. Our primary mission is to support critical internet infrastructure. So that basically means we provide assistance to the startup and growth of internet exchange points, and we run a large Anycast DNS network for CCTLDs. And that's a service that we offer at no cost to all as part of our non-profit charter. And very recently, we also started a shared DNSSEC hardware signing platform. So any CCTLD managers, if you're perhaps interested in what we do here and how we might be able to help you, then do hit me up afterwards. So the peering survey that we performed recently, there's a complete paper on this. It's a PCH.net resources paper peering survey. That's the complete paper from which the data and the presentation here follows from. So the peering survey, we called it the 2011 peering survey, but the responses started coming back from about October last year. So I guess it depends on your definition of year as to what it is. But it basically provides a statistical overview of peering sessions that were for a research paper, which was to provide input to an OECD paper. The data that we were collecting, we were trying to keep it nice and simple while still being able to get something useful out of it so that people would actually respond. Right? If we put out questions that required too much thought and too much typing, we weren't likely to get them back. So the things we were looking at, we were specifically asking for your ASN, your peer's ASN, whether or not it was a written and signed peering agreement, or if it was something far more informal. Whether the terms were roughly symmetric, where the terms between each parties were the same, or they were somewhat asymmetric, whether that's receiving less routes than you send, or perhaps paying for something, or some other condition. And lastly, if there was a jurisdiction of governing law defined for that formal contract. And then, of course, all this data was anonymized, so we stripped the ASNs after we'd looked at everything to preserve privacy. So what did we find from this? Well, the Internet's comprised of around about 5,000, I think it's probably closer to about 5,100 now, ISP or carrier networks that are basically transit ASs. So the definition of that is basically an AS that has another AS sitting behind it, right? It's got customers with their own AS behind it. The Internet, as we've heard quite a lot of today, is made up of both transit and peering relationships, and we're specifically interested in the peering relationships. So it's these that allow carriers to exchange the traffic bound for each other's customers, and it's really the value creation engine of the Internet. And if you paid attention to the peering game, you would have seen that there is real value created when you peer, right? And that value is the fact that you're not having to pay somebody else, your transit provider, to carry that traffic. So out of all the responses we got back, we got a total of 142,210 interconnections to analyze. So it's a reasonably large data set. Of those responses, it represented around about 4,300 different ISP networks. Okay, so again, these are the transit AS networks. So that's about 86% of the world's internet carriers. So it's a reasonable sort of data set. This covered 96 countries of incorporation for those networks, and that was all 34 of the OECD countries, which was important for the report that this was providing input to, and 7 out of 48 of the UN's defined least developed countries. Okay, so some of the results we got out of this. Well, firstly, in 1,000 cases, both parties to the same peering agreement responded to us. Okay, that was important because by looking at that, we saw that 99.5% of those cases, the response we got from each party to that peering relationship were identical. Okay, so that told us that it's highly likely that the respondents understood the questions clearly and were able to respond accurately and unambiguously. Okay, so response by country here. So the largest networks by country that were represented in this data set were the United States, which probably to be expected, followed by Russia, the UK, Germany, and Brazil. All right, so we've got these shown on a graph here where we've got along the bottom the various countries ordered from greatest proportion to least. So we can see the US and Russia right up the top. Now the red line here, the red line actually shows us the actual number of transit networks in those countries, right, according to the RAR data that we could look at. Whereas the blue shaded area here represents the actual responses we got. So there's about 45 countries out the tail end there that represented 3 networks or less, right? So we've got a lot of data a lot of thin data out the end there. Interestingly here, although we got a large number of responses from the US and Russia here, it's a comparatively smaller proportion of the total networks there. And that had the effect of potentially skewing some of the analysis that we were able to do on that. Okay, so firstly, looking at the agreements, whether they're informal or formal. So we got 698 responses that had formalised written contracts, so a shade under 0.5%. So that's a pretty small number compared to the other 140,000 odd, which were basically handshake agreements. Okay, so based on an informal terms or commonly understood terms. So a lot of peering, happens when one party emails the peering coordinator at the other party and says, "Do you want to peer?" And oftentimes they'll just say yes and set the session up, and that's the only real sort of agreement there. Or likewise, it might be a meeting in person, such as a forum like this. So the commonly understood terms tend to be that only customer routes are exchanged. BGP4 is going to be used, obviously, and each network is going to exercise a duty of care to prevent abuse and criminal misuse of that peering link. As I said before, most agreements are formed by peering coordinators or interconnection staff or something like that, and often happens at forums such as this. Okay, symmetric terms. So again, the vast majority of respondents told us they had symmetric terms for their peering sessions. So it was 141,000. And what that means is each party to that peering agreement give and take the same terms. So by far the most common. And then there were 374 that responded that had asymmetric terms. So this is where there's different terms offered from one provider to the other. So it could be one party pays the other for what they're getting, so the so-called paid peering, or perhaps a requirement for one end to meet some minimum peering requirements, which minimum peering requirements are often stated by the larger carriers that think they've got, like the tier ones or others that feel they have a little bit more sway. They might say something like, if you want to peer with us, you have to peer with us in, say, 10 locations. And you have to have traffic above a certain volume that's coming to our customers. But again, that was a pretty small proportion that had asymmetric terms. Governing law. So in all cases, we found that the country of governing law was the location of one of the parties involved in that peering agreement, or, the country of incorporation for that company, or where their primary operations are. So what that tells us is no country appears to have a compelling rule of law that makes setting up an interconnect under that jurisdiction any better than any other country. All right, so there's no equivalent of a tax haven or something like that for interconnects at this point. So there's still a clear preference, though, for the country of governing law, which we can see in the next chart. So this shows us the probability of selection as a country of governing law for that peering session, the 10 most likely and the 10 least likely. So we can see that for the US and Canada, it's highly, highly likely, almost, it's almost a 100% probability of the US being chosen. If you've got a peering link with 2 networks, one from the US or Canada and one from any other country, it's very likely that it'll be the US or Canada that has the rule of law for that particular peering relationship. And then as we carry on down, we see once we get down to places like Russia, that has almost a zero probability of being the rule of law there. But as I mentioned earlier about the responses that we got back from the US and Russia in particular, it was a relatively low proportion from those countries that we got responses from. So it does skew the data somewhat there. We can still make some interesting observations here. If we look solely at the frequencies with which pairs of countries of incorporation appear. So we can chart the relative number of connections between any one country and all others. But again, we need to be careful of the selection bias that we've got from the low response from US and Russian networks. And that basically shows itself up as an unnaturally low number of domestic interconnections in those countries. Denmark, Hong Kong, Australia, common sort of trading partners there. Whereas in Russia, we see that they tend to be connecting more with geographically close locations, as well as sort of linguistic-based connections where you'll find a lot of networks connect with other networks that have content they want. So if the language is the same at both ends, you'll often see that. But if we contrast that to, say, the UK and Germany, we see a far higher proportion of domestic connectivity showing up here. And at the same time, again, it's mostly sort of geographically close countries that the majority of these peering sessions are taking place with. Or in the case of Germany, there's also a linguistic component as well. Right, so the degree of interconnection. So what this graph here shows us is the distribution of the number of networks along the horizontal axis, and that's charted against the quantity of interconnection partners up the vertical axis. So what it says is that there are sort of a large number of networks sort of from 1 to 100 here, as in many networks had 1 to 100 pairing sessions, right, based on the responses we got. And that sort of tails down, we can see, as we move along. Now, out of that, there's a couple of spikes here, which we've sort of put a label on here. So a spike around about 140, 150, and 250 odd. So the first spike is actually corresponding to the Hong Kong Internet Exchange's multilateral peering agreement. Okay, and why we see a big spike there is because there's a large number of members all peering with the route server there, so they're all receiving the same number of routes, which is why we see that that very narrow and tall spike. And we see the same thing in Warsaw at the Internet Exchange there and the Frankfurt Internet Exchange.